being replaced by a device.
And we have hit 12:30. So welcome everyone to our second seminar, Computer Literacy Seminar. This is a seminar series co-hosted by the University of Washington Tacoma's Information Technology Department, as well as our Center for Data Science. So very excited that you guys are all attending. We've got 2 people in person and some more online. Thank you so much for attending. This was put together by students. It is funded by STF, and we're very thankful for that opportunity. Today's talk will be on the introduction to Git and versioning. And just like last week, we have Tom Capaul here again to teach us on that. And I will turn it over to you, Tom.
Thanks, Caitlin. Yeah, good afternoon, everyone. I hope you're on a nice dry spot. It's a rainy Puget Sound day in January. And so no better time than to be inside. And so we're going to talk about this Git thing. So we're going to learn about versioning, code versioning. And yeah, it's something that as a software developer working on a team of developers, it's a really important process to go through. It's a must-have tool in this day and age. But we're going to find from the discussion that we have here as we work through the slides that the notion of versioning is not something that's unique to building software. It occurs all over the place in everyday things that we happen to do. And so yeah, why Git? So first of all, and we'll get into some more details of what Git can do in just a bit, but it's the most popular versioning tool that's utilized by software developers. That's why we're talking about it. And so some things to consider. The current programming landscape, and it has been this way for decades, is a collaborative environment. You are going to work with others on code because there's a lot of code to write, and you have to have multiple sets of eyes. You need to be able to share the code. You need to be able to manage the code, and we're going to find that this is what Git helps us with. And so as an example here, Windows 10, we've moved on to Windows 11. I don't know if you've put Windows 11 on your machine yet. I'm still running Git 10 on mine. I keep getting reminders that say Windows 11. Any of you guys running Windows 11? Yeah. Is it good? Yeah. Should I do it? Should I just say yeah? All right. Anyways, 50 million lines of code. 50 million lines of code in Windows 10. Now it's an operating system, does a lot of things. And so, yeah, necessarily it's big. It's got a huge code base. And so furthermore, 4,000-ish people work on designing Windows 10. And so one of the things you have to understand is they're coming and going. So not the same 4,000 people are there. So there's this necessity to manage that code and to keep track of the changes that have been made to the code and have the ability to go back to perhaps older versions of the code. And so these kinds of things are what Git supports, and Git being a version control. And so, so how can we enable the collaboration? In this day and age, for a programmer by themselves to build any kind of application, code-wise, very big, it doesn't make sense for them to keep all that stuff on their own machine and then maybe, I don't know, email it to someone, right? That sounds pretty silly, and it is. So it's just not feasible. So yeah, why do we need Git? And what does it help us with, really? It simplifies how you store the files, those files containing the code for your software. And there can be support files as well. We'll find out, you could use Git to store images, video, all kinds of things. It has the ability to do those things. And so remember them long term. And then it has some other nice things with regards to code when you end up with 2 different versions of the code and you want to put it together in a single file. So other things it does certainly makes collaboration with others easier. We'll find that with Git, there's the notion of a central repository, even though it doesn't have to be used that way. That's how it's typically used. There's a central repository, on some machine, some website, who knows. We're going to visit GitHub as part of the demonstration that will be the second part of this lecture. But it sits out there so that all the developers that need to access the code have the ability to do so. And we're going to find that Git lets you take that code that's at that remote location and bring it down to your machine, let you work on it. And when you're done, check it back into the remote location so that others can work with it. So super nice thing, super important. Other things that it helps us with is bug reporting. So inevitably when you build code, there's bugs, there's problems. And so Git, as you make changes to code, one of the things that we'll find that it has us do is put a little entry in as we say, all right, we made changes, Git, we want you to save this long term. And it says, well, tell me what changes you made. And so you can say, well, I'm working on this bug. There's this problem here where, we've got this value that we're calculating, and for some crazy reason, it comes up negative. So it's not supposed to be negative. And so, you can put that information in as part of the reporting process with Git. And certainly all these things I just mentioned improves the overall quality of the process of building software, so developing your software. So what's version control? And so we'll just abbreviate VC here on the slides. We already got a feel for a lot of it from the little bit we've talked about so far. So it's a system that coordinates changes to files, right? There's certainly more to it than that, but it's about files, it's about remembering those files, and keeping track of the changes that have been made and allowing those files to be distributed so that different people can work on them and then bring it all back together in a single location. So yeah, some of the capabilities of version control not only stores the software, so the code, but also as we begin to discuss the history of changes to the software, and that allows us to record when perhaps harmful changes occurred, and so that helps improve reliability of your software and really of the process of building the software. Also permits others to immediately apply needed changes. So it could be a bug fix, mentioned bugs, problem in the code. Oh, someone might have fixed it, they worked on that on their machine, all right, fixed it, and so then they can send that back up to the remote repository for others to work with. And so most definitely that improves collaboration. What else? It allows others to edit your code. And speaking of bugs, once again, report those bugs. And so not only are we improving reliability, but the quality of the software as well. And so everyday life, the notion of version control can arise in many different places. And so if you keep a journal, okay, it could be for work, it could just be, it's almost like a diary, your daily activities, those kinds of things. That's a version, it's the same thing, a journal, and then you add to it on a daily basis. You have different versions, and you like to go back maybe sometimes and look at those previous versions, okay? Many of us have used Google Docs. It's a very normal way for us to, well, share files, whether those are word processing documents or spreadsheets or who knows what else. But Google Docs, that's version control for writing code. And so, yeah, you're especially doing versioning if you change the name of your doc to include a version number, so here's, business plan V1, and then you do business plan V2. So, well, what's the V? It's for versioning. So yeah, you naturally want to do this, and so Git and this notion of version control is a natural thing to want to do. And so what's Git all about? So we're digging a little more deeply into what it's about. So it's software that permits us to see code changes and save alternative versions of our code. And so the alternative versions, we can create what's known as a branch. Okay, and so we'll see when we do the little, when we look at a demo here, the second part of this lecture, we'll see an example of a branch. But think about, don't worry about writing code or anything. Think about you branching out and doing something different. Like, well, I've got this set of things here. Based on what I have here, I'm going to branch out and try something different. Okay, so that's a term that we use sometimes, and then then you can come back from your branch too, back to where you were before. And so we'll find that Git and versioning lets us do that as well. Okay, so Git can be used to modify and record changes to any non-binary file. And so what's meant by non-binary here, more or less, is just text, plain text file. Okay. Do understand that the Git is not necessarily just about code. Okay, anything that's plain text, it can very easily version. I mean, the fact is, even binary files, you can check those in to your Git repository, and thus they're saved and stored long term. You just don't typically, with those kinds of things, you don't typically want to have multiple versions, for example, of some kind of a multimedia file. Maybe you've got a little video that you recorded. You don't want two versions of those. Git's not going to be able to merge those for you. It's not smart enough. you're going to have to use some kind of obviously video editing software to do those kinds of things. Git, we'll find, is limited in terms of what it can merge to things that are plain text. So if you've ever used, Notepad, something like that, that's plain text. You don't even specify fonts or font sizes or anything like that. So really simple. And so, yeah, not only can it let us do that, it sort of allows us to make sure our software is more fail-proof. Because of the fact that Git lets us remember, we're going to find they're called commits, but you have a version of a file, you commit it into your repository, then you make changes and you commit it again. Okay, and so like they're talking about, like if you kept a daily journal, okay, you've got different versions, and what Git will let you do is, if you need to, it's like, well, I want to go back to this other one over here. Let me go back a few pages, so to speak. And so the good news with Git is it remembers long-term. Once you commit something, once you save it to the repository, commit is more or less saving, okay, that version of that file is remembered, quote, forever. Okay, you don't have to worry about, well, I just want to make some changes and stuff that's going to ruin what was there. And this is another important reason you want to use Git. How many times have all of us, never mind writing code, you're writing a paper or something, and you overwrite something that was there before and you can't get to, what was there before, and you try to hit Control Z, or you go up and say undo, and it's like, oh, darn it. Especially if your computer crashes and the software didn't have a chance to save the document for you, or an emergency recovery. So the nice thing about Git, a beautiful thing about Git, I'm in a good place with this file, this code. I'm going to commit it. Okay, it's saved. No worries. No one can break that code that you've committed. It's there. Okay, and so that's a really nice thing. Any changes that you make, you can't make a change to that. It's committed. Changes you make, what Git will tell us is, well, you made changes, you need to do a new commit. So it's really nice. It provides this little safety net, security blanket, however you want to describe it. And so it's so nice. Yeah, so you can store multiple versions of the same file. Imagine having the ability to store multiple draft papers, right? Combine some of them or discard some, depending on further paper writing process. And so a similar idea here applies with regards to what Git can do for us. Okay, and so then getting to software, writing a robust program requires all of these capabilities. Because programmers, okay, we need to communicate and follow what's called iterative development. And so, if you haven't played this programming game and built software, iterative, okay? You start with something and then you repeat it again, you iterate, all right? Now, there's another word that we can throw in there with iterative called incremental. Most software in this day and age, you build incrementally. And it's a natural thing to want to do from a problem-solving standpoint. Let's get this little bit of functionality, okay? And then we'll add to that, okay? And so when you're doing that, you're versioning. So you've got an initial set, and then 1 week you do this, and then the next week you add things to that. So that's the iteration that goes on. And so Git, and any kind of version control, but Git especially, makes this easy for us. So who can use Git? All right? Anybody or all people who need to work on some shared files could benefit from understanding version control, and of course our focus is on Git better, right? While it's used mostly in software development, okay, we already mentioned this a few slides ago, you can use it for many other things. And so we're gonna get a peek at GitHub, second part of this lecture today. You can place all your team's programming files on a GitHub repository, stored online, record the amount of work you had, the team put in. But the other thing is it doesn't have to be just source code and plain files. You can save all kinds of different things, and then you can get new versions of those, and you can commit those and save them. Going back to Google Docs, all right, it effectively contains all your versioning control capabilities for whatever word processing document or whatever you want to build. All right, and so now we're going to move to the details, the underlying details, the different things and some of the different commands that Git is designed to interpret. Okay. Oh, and by the way, a quick thing here, a quick piece of trivia regarding Git. Git was actually developed by a single individual, right? A very famous individual in the world of computing. Okay, the name of the individual that built Git is Linus Torvalds. Okay, Linus Torvalds. And so if you have done any kind of computer science things, he is creator of this little operating system called Linux. Okay? Linux is named after him, the Linus, but it's an offshoot of Unix. And so, of course, Linux is all over, is used all over the Macintosh operating system. It says it's Unix based, but really it's mostly based off of Linux. So pretty important guy. He built Git. There's your trivia. Who knows? That'll come up someday on computer nerd trivia. So let's focus here on this slide. Right? Most of Git is, or most often it's used for software development. We've talked about that. And GitHub is the most popular platform for using Git. All right. Now you can use Git on your own machine. All right. There's software that you can install. It's pretty straightforward. Okay. But GitHub, it's web-based, so you use it with your browser. It turns out that GitHub also has a little GUI application, graphical user interface, that you can install on your machine that might let you do some stuff that's a little more fancy than just the web-based interface. But the fact is, just using the web-based interface is oftentimes good enough. And so yeah, as I just mentioned, your computer can run Git and it can maintain multiple versions of the same folder. And so even if you're not going to collaborate with other people, on code, it makes a lot of sense for you, if you're writing your own code, just to use Git on your own machine. And also, we're going to find out, I hope we'll have time, I'll show you that it is so crazy easy to, with some of the code development environments, and I'm going to show you this thing called IntelliJ, how easy it is, PyCharm. I said IntelliJ, PyCharm, we're doing Python. How easy it is to wire that into GitHub. And you can send your code back and forth between GitHub and your local machine. It makes it really, really simple. So yeah, one of the most important features of Git is the ability to allow you to store different versions of the program. We've said that again and again. It's a key thing, and so we bring it up again and again. And so Git allows you to do, so here's some terms, here are some commands. Merge, which we'll find means when we've got two different versions of the same file, source file, put them together into a single file. Push, we're going to find that says, hey, we've got some code here on our local machine, and we want to send it to our remote repository. Maybe it's on GitHub. It doesn't have to be GitHub. It could be another developer's machine, and they could be located on the other side of the planet for that matter. Git will allow that communication if you want. But push just says, take the changes that I've made on my local machine and send them to some other remote location. Pull is the other direction. Pull is the other direction. Okay, so maybe on GitHub, some other developer that you're working with had pushed things up there, and so you want to get what they just put up there on GitHub so you can pull it down. Really simple notion in terms of what these do. Mention branch. Okay, so Git, we're going to find out, works with branches. By default, when you start off a repository in Git, you're on what's called the main branch. It's literally named main. It's the main branch, and so that's the main location for your code. But as part of developing software, it's fairly typical to want to go off and try other things. So you make other branches to test different things out. If you're working on a team of developers, a lot of times each developer will have their own branch, maybe with their last name or something, first name, last name, something that uniquely identifies them to the organization. And so then what that allows for is, yeah, you got your main branch, but you have your developer branches, each person developing. And then when somebody's got something that's ready for everyone else to use, then they can merge those things onto the main branch. And then others can go to the main branch and grab that stuff. Okay. Now there are nuances to doing this merge stuff and grabbing things, and you do need to coordinate things, and there are rules for the main branch. One of the things is like the main branch, you keep everything on there clean and pristine, and you should probably have some oversight in terms of who gets to put things on the main branch, but that's for another talk another day. So and then finally, there's more commands, but on this slide here, there's clone. All right, and so clone, make a copy. Make a copy. And so Git makes it crazy simple to, once again, I'll refer to GitHub. So let's suppose there's a repository on GitHub. Here comes a new developer just added to your team, okay, they're fresh out of school, they got their degree from UW Tacoma, of course, all right, they're ready to go to work, they're ready to get paid, and so they need to get access to this repository. And so what clone does, clone just says, hey, I would like to make a copy, a complete clone of what's here on GitHub, for example, to this local machine. It's just a single command, okay? Yeah, there's some nuances to it, but fundamentally it just makes a copy. And that's it, it's a copy. And so then it's on that new developer's local machine, they can do whatever they want, and it doesn't affect what's on GitHub, all right? From what we talked about, if they made some changes, and then they wanted to move those changes to GitHub, what command would they use? Commit. Okay, would they use, that's very good. First, they would commit it on their local machine, but then to move it from their repository to the remote one, they do a push. Yeah. Okay, it's not, see, I mean, it's not tricky stuff. It's not supposed to. So here's some sample Git commands, all right? And the subsequent slides will talk about these. But Git init creates a repository when you don't have one. Okay, we'll find out it just makes a folder. And inside the folder, that's the thing, a repository is just a folder. Okay, or a directory if you want to use the geeky term. But it's just a folder on a machine. And inside there, you'll put all the files that you want to keep track of, that you want Git to keep track of, and version. All right, add is the process of telling Git, hey, I got a file here or set of files that I want you to kind of watch what's going on with these. Okay, and so we'll find, and then there's a slide that tells us that add moves a file to what's called the staging area. And so then what it just means is Git's watching what's happening. If our changes being made to that kind of thing, and we can ask Git and it'll let us know, oh yeah, there's some changes that have been made to this one. So hand in hand with that is commit. All right, and so commit, that's what formally says, save this thing forever. Save this file into the repository. The fact is when you do a commit, what Git does is it numbers each of your commits. Turns out it uses a really long number. And the reason for that is it wants to try and uniquely identify each commit so you can always go back to different ones. And so yeah, really big number. And that's part of the whole versioning thing. This is commit number, whatever. Okay, there's git log, it's actually singular. And log just lists the set of commits that you have. Okay, so it's more or less gives us a history. Okay, we already talked about pull and push. All right, we'll find out that merge says we've got this file over here on this branch we work on. We made this branch over here to do some testing, some new things. And then here's our main branch, and it's got the same file. Okay, and so what we're ready to do is we want to take the changes that we have here on this other branch where we're trying new things. We're like, this is good. We want to move it to the main branch. And so merge says take a file or set of files from some other branch and move them into, I mean, you can specify which branch you want to go to, but for the example I'm talking about is, let's put that stuff in the main branch. And are there nuances to that? Yeah. Okay, I hope to do, not hope, we'll do an example. I already talked about clone. Branch just creates a new branch. Okay, oh, I want a new branch to do whatever, try some things out. And checkout is what we can use to move from one branch to another. It's like I'm on the main branch, I want to go to this other branch, or this other branch. And the cool thing is, you make as many branches as you want. Okay, you make as many branches as you want. And sometimes what you do from a development standpoint is you'll make a branch, try some stuff out, and then you're like, okay, I don't like it. You can actually delete the branch. Or another thing you can do is, I'm going to go off this branch to try some new things, try this new stuff. Oh, I got it to work. Okay, so I'm going to merge what I did over here onto my main branch maybe. I don't need that branch anymore. You can delete it if you wanted to. Okay. The good news is when you're just doing source code, it's just plain text. It doesn't take up a lot of memory. So you can have so many source files in Git, and you don't have to worry about, oh, I'm going to run out of memory. Okay. And the way that Git remembers the files, it turns out that it doesn't save the entire version from scratch every time. What it does as you do different versions of the same file and you commit them is it just remembers the changes. So it efficiently represents the files underneath. It's not something we have to worry about, just some kind of geek trivia because I'm a geek. So proudly a geek. And so yeah, Git is similar to creating a folder and initializing your repository. All right, and so a repository, I've been using that term. It's a space where your files are tracked for changes by Git, recording the complete history of changes. and the repository holds all of your commits. Okay, and so Daniel, who's running the slides for me here, Daniel, sorry, he went ahead and did on his machine. So from the command prompt or the terminal, he shows us, here's how we do init. Turns out that all Git commands start with Git. That's pretty easy. Okay, but I'll tell you, when I'm not paying attention and tired, when I'm doing stuff from the terminal, sometimes I'll forget to put Git first. And I'm like, why didn't it commit? I type in commit. This is not a recognized command. Oh, yeah, don't forget to say Git. Okay, add specifies Git should start tracking and saving the history of changes. It moves the file into what's known as the staging area. So the way Git works is, here's your file, you're working on it, it's in that folder that's your repository, and so it's considered untracked. Okay, and Git will actually notice there's a command called status, you can type git status, and it'll say, oh, you got this file here, you got these 3 files, they're untracked. And so what untracked means is you haven't done anything formal to make Git acknowledge them, and so you're like, well, I want it to formally acknowledge these things and really watch what's going on. So that's what add does. Add takes them from untracked and moves them to what's known as the staging area. So the staging area is like right before you actually put it into the repository, and that's what the commit command does. And so when it's in the staging area, you can make some changes, and then, or you could like remove it from the staging area. It just gives you some flexibility to decide, I'm not ready to commit this formally. So you wait for a little bit to decide whether or not you want to do that. So that's what add does for us, and Daniel shows the command right there. And then commit. Okay, so that'll take what's in the staging area, so what you've added, that add command, and then formally remembers the file or set of files long term. Okay, they are permanently remembered at that point when you say commit. They are safe. You don't have to worry about them being overwritten, any of those kinds of things. And so yeah, it moves a file from the staging area into the repository. The other thing that we find is that anytime we commit something, Git requires us to include a message that describes, okay, well, what is it you committed? Or if it's something that's already in the repository, you can say, well, I made a change to this file, I fixed this bug, or I added this other feature for behavior. So yes, we mentioned earlier that Git keeps track not only of the changes physically to the files, but we put notes in that describe what's going on. And so this is nice. When we do a Git log, it'll show us the commits, but in each of those commits, there'll be a message that went along with the commit that said what happened. So if you do a good job of properly specifying what change it is you made, then all that information is there for you later. So yeah, Git log returns a list of the commits. It's a history of your commits, as I just said, with what was included with each commit. All right, and so what Daniel has here is when he did Git log. Here's where it shows commit. So remember I said there's a really big number? This is a number. Now, when you look at the number, you're like, well, there's letters in there. Okay, however, there's a specific subset of letters from the alphabet, and some of you might recognize, what kind of a number is this? What base? It's base 16, so it's hexadecimal. All right, so we're used to decimal, base 10 digits, 0 through 9. Hexadecimal has 16 digits, 0 through 9, and then A through F. So we're not here to learn about hexadecimal, but trust me, that's a number, and there's reasons to represent things in that fashion. And so yeah, so Daniel's got this demonstration commit. So that's the message that he included. So that's what log does. It shows our list of commits. Branch, all right? And so yeah, it's like imagining an alternative way of doing things, an alternative history sequence where something else happens. So it creates an alternative version of your repository where you can modify the code base without affecting the original. So here's the thing. You're on the main branch, let's say. It's like, I got this main branch, okay, everything's good, it's clean, it's pristine, but I want to try some new stuff. Okay, so let's make another branch. And so the way that Git works is that when you create a branch, it bases it off the branch you're currently on. And what it effectively does, all right, I'm going to put this in quotes because it's a little bit of a lie. It copies everything in the current branch to the new branch. Now, the fact is, the little lie is it doesn't truly copy everything because Git just keeps track of changes between files and it'll know, hey, I'm on a new branch now. So any of these changes that were made to over here are specific to this branch. So, off you go, and you can try out whatever on this new branch. That's the idea behind it, and it's a very normal thing to want to do. And Danielle shows us, here's a possible way to create a new branch. A little bit confusing because there's a branch command, and he used checkout, but the -b will actually help us create a new branch if it doesn't exist. Okay, and so then checkout lets us switch from one branch to another. So, and it can be really simple. It's just get checkout, and then you can list the other branch. By putting the -b, if the branch doesn't exist, it'll create it for us. Right? We're not going to learn all the nuances of all these commands. We just don't have time. Okay, and so then here's merge. Okay, and so what Daniel did for us here is he did a checkout. So he moved to master or main branch. The main branch used to be called master. Now it's called main. So, and then he's like, well, let's merge. All right, we're on the main branch here. Let's merge the development branch. And so here's all this stuff saying, oh, there's a couple of files that were changed and then some insertions. And so, this is crazy looking stuff. All right, when I do a demo, and we're almost at the end of the regular slides here, I'm going to do a demo on my laptop, and I'm going to go to GitHub. And everything will be through a web interface. And you're not going to be like, what's going on there? It's like, I see some red, I see some green, and I see all these numbers, and I don't know what it means. This is just to show, that at the most raw level, what's going on with Git. You don't actually have to do things from a terminal or command prompt if you don't want to. Okay. Clone. Make a copy. Talked about this earlier. This is where you're going to make a complete copy of an existing repository that's located remotely. And so what Daniel did here, did git clone, and so he's got a web address, https://github.com, and so there's his account. All right, and then here's the repository here. So looks like somebody took my software development course. So we did. We survived. And he's here. And he's smiling. That's close. Okay. So we see cloning into. So it brings it down locally. All right, and it says complete authentication in your browser. So there's some handshaking that has to go on because you're accessing something on GitHub. It's not just going to let you blindly access something. You got to show your credentials. And so that's what this message does here. Oh, the good news with Git and GitHub is that once you've shared those credentials, Git can remember it long term so that subsequent communications with GitHub, you don't have to enter your credentials again. It's kind of like, you'd hope would be the case. So this makes a copy. That's fun. Push. We've made some changes locally. Okay, that have been committed. I'm really glad you brought that up. That have been committed locally. All right. And then we were ready to move this stuff to the remote repository. And so the super cool thing is when you clone a repository from GitHub, it turns out that, okay, I made some changes here locally. Then all you have to do is say git push. Because Git will remember you cloned this repository that lives somewhere else. You don't have to put in the web address again and all that. It remembers it. It's quote as easy as it should be. Now, the very first time you do stuff, there's some handshaking things that need to go on. And there's some things if you create a new branch and you have to make it, you have to do some upstream stuff, but little nuances, but there's plenty of examples of those things. And that's for another deeper lecture on Git. And so it pulls the other direction. From GitHub, there are some changes that were made. I want to grab those changes. Okay. So for the students in my 360 class, we use Git, all right, and GitHub, and it's a normal thing. Usually we have three members per team, and so each person will do some stuff on their own branch, and then they'll move it up to GitHub, and then the other team members can pull that stuff down. Okay. So first you do a clone, and then there's a bunch of pushing and pulling. Okay, and so now we've reached the point where we're going to switch. I'm going to switch over to my laptop, and I'm going to give you an example. So I got to probably wake my laptop up. Oh, it's awake. I do want to switch over. I'm going to switch the video here. You don't need to look at me. So I'm going to switch to HDMI. There's my laptop. Okay, You might have cool background pictures. I mean, they're all over the place, but this place, Digital Blasphemy, I've been going there for years. They have all kinds of science-y fantasy pictures that are just fun. So, anyways, let me stop the screen share here. Yeah, that should be fine. Okay. And so now, hey, what's it doing there? Gotta figure out, I got a couple of browsers open here. All right, so make this just a little bigger. And so I'm on GitHub, I've already authenticated. And so what I'm gonna do here is I'm gonna create a brand new repository. Ooh, I just realized there's a video here on hold on just a sec here. Let me go to video settings. Let's make it HD. Let's not mirror it. And so I think that should clean things up a little bit better. Okay. And so, yeah, on the screen, you can see that earlier, well, 3 hours earlier, workshop test. This is the workshop. And so I did a test. All right. So never mind creating an account. Oh, by the way, GitHub is free. It's free to use. Price is right for us. So there's some professional level things where you could pay them some money, they'll take your money, but it is free to use. But I'm going to go here and I'm going to say new. And so it tells me, or it says, oh, you want to create a new repository and it has templates. We don't care about that. And so I'm going to do CLS workshop demo. And Git keeps track of what we're doing and it tells me, hey, that's available. Okay. And so I can give a description here and just say, this is a demo repository to hold. Well, it's just going to be a Python file. We're demonstrating branching, committing, and merging. Right? So there are options for public repository, which is the default, where you can make it private. I don't care that anyone sees this. Some other things real quickly. A README file. The README file, well, what are READMEs for? It's like, well, README, I have interesting information about this repository, for example. So I like to have GitHub include one of those for me. It's nice. It's just basic information about the repository that you can edit. The other thing that it shows us here, and I'll bring it up just for grins and chuckles, is there's this thing called git ignore. So when you're working on software, there are some files you want to version and there are some that you don't. There's all kinds of support files that you don't care to include in the repository. And so Git has this little file, this is a plain text file, and inside, we're not going to look at it, but it just has a list of, hey, any files with this extension or in this folder, this kind of thing, it's like, ignore those. I don't want to version those. And so it has some templates here that we can use. And so I'll just, even though it's not mission critical for us, it's easy enough for me to show you. Here's a template for Python. It's like, give me the git ignore for Python. Let's put it in there. Okay. So if you're doing Java, there's git ignore for Java. If you're using a specific IDE, PyCharm, IntelliJ, Eclipse, who knows? There's ones that are built for that as well. Okay, so now I'm going to hit create repository. All right, and here we go. I've got a repository. And so there's a bunch of stuff going on, but the things to note that is that I'm on the main branch, and so that's what gets created for us by default. So I'm on main, and there's only one branch, and it is main. And I see here Tom Capaul, that's me, I'm the one that made it. And inside the repository are two files. What it's showing me is the files. And so there's that .git ignore, and then here's this readme, okay? And I can click on these if I want. And so the git ignore is just a list of files and directories to ignore when you're versioning. And there's just a ton of stuff here that I've never used and probably never would, but it is an important piece. Okay, and so now I'll just go back to that screen I was at before, and I can do that just by clicking on the name of the repository. Okay, and so what I want to do now is I'm going to add a file. Okay, and I'm going to upload a file. Okay, and the file that I'm going to upload is workshop CLS. And so for those of you that attended last week's workshop, there was a little Python program where we had a list of test scores, and then we found the high score and we found the average score. And so I'm just grabbing that from last week. For those of you that are like, I wasn't there, it doesn't really matter. I just need a file, okay, to version. And so I just chose the file. It shows me right there, testscores.py. And now it's going to add this to my repository. And so Git, I mean, it's GitHub, but Git wants a message. It wants a message. All right. And so I'm just going to say upload of Python file containing test scores and finds. And so notice it tells me, pro tip, great commit summaries contain fewer than 50 characters, place extra stuff in the description. Okay. And so, okay, I'll do that because I can. And so I'll just paste this, and it finds, and I'll just leave the and there. It finds average and high scores. Okay. And so then down below it says commit directly to the main branch, or I could create a new branch. So I'm going to keep it simple, and I'm going to commit it to the main branch. And so it tells me processing. Might take a few minutes, I hope not. When you have a whole bunch of files, it'll take a while. And so there it is. Okay, there's my file, testscores.py, and then there's a little commit message, upload a Python file containing test scores. And I can look at it. And so here's where GitHub has evolved quite a bit. So I just click on it, and it shows me the code. So I've got some comments here. Simple program to demonstrate conditionals, loops, processing list data, and output. All right, and then the associated code that goes with it. So the other thing that it does is it'll actually let me edit the code. So it has a little plain text editor. Now, it's not normal as a software developer to edit your code in GitHub. So you're usually going to do it on your local machine with some kind of an IDE, integrated development environment, that makes code writing much easier than doing it here. But for quick and dirty stuff, this is fine. And I'm actually going to use the editor in just a sec. But I'm not going to make any changes right now. I just wanted to show you that. So I'm going to click, okay, to go back to, there's my main repository, there's the files. And so what I want to show you guys now, okay, so what I want to show you now is, so we can do some things with the code. If we ever wanted to make a clone, here's the address. There's some other things we could do. We could download a zip, all right, if we wanted to. So, but what I really want to do is I want to create a new branch. I want to show you, okay, we've got some code that does this high score and average score of these tests. And let's add some code, also do a low score. Pretty simple stuff. And so, but to explore that, I'm going to make a new branch. And so when I click over here under main, because this is showing me the main branch, it's got a message that says find or create a branch. And so I'm going to put, I'll call it low score branch. Okay, and after I type that in, here's a little option, create low score branch from main. So here's the thing, when you make a new branch, it's going to be based off of your current branch and what you've committed on that current branch. And so what have I committed? Well, I suppose there's the README and the .git ignore from before, but I added that Python file. So yeah, create me a branch, please. Okay, and so now I have two branches, and it'll move me to that low score branch. Now it shows the same set of files as before. That's because this branch is based off of the branch I was on when I created the new one. And so what I can do here is under test scores, I can click this and I can go to test scores. Let me make this just a little bit bigger, right? And I'm actually going to edit it. And what I'm going to do is, I'm not going to put in comments in the interest of time, but I want to find a minimum score as well. So I'll add just a little bit of code here. So I'm going to have a variable called min score, and I'll assign that to the very first test score, right? And you know, it's not important that you understand all the Python code. The other thing I'm going to do is I'm going to go down here into this loop, and I'm going to say if the score is less than min score, then I'll remember that as the min score. So similar kind of logic to what I did with the maximum score. And then finally, I'm going to go add one more line of code here where I'll print out lowest test score. Okay. So this lecture isn't about the basics of programming. That was last week. And so I made some changes. And so commit changes, and so I'm going to put a message here, added code to find and print low score. And I'll just leave it at that. And so then it tells me commit directly to low score branch. I can make a new one. No, I want them to go right here. So I'll commit changes. Okay. And so it did it. It did it. And so what I'll do now is I'll go back to, I'll click on just the main repository, and it tells me low score branch had recent pushes less than a minute ago. The other thing it tells me is this branch, the low score branch, is one commit ahead of main. So I made some changes to this low score branch, and Git's telling me, or GitHub's telling me, oh, it's Git. Hey, there's a little bit of difference. Do you want to do something about it? Yes, I do, before we run out of time. All right. And so, yeah, this one commit ahead of main, I could go right here, compare and pull requests. I think it ends up doing the same thing. All right. And so what it does, actually, I want to back up because I want to see, let me back up. So one commit ahead of main. Okay, this is what I wanted you to see. So this is the thing that Git can do. All right, a little bit hard to see, and I know that I've got HDMI going, but what it highlights is in green it shows on lines 16 and 17 there's something new. On lines 31, 32, 33 there's something new. Okay, and then on line 44 there's something new. Those are all the lines of code that I added. So because of how Git does things, it's pretty easy for it to tell. Here was the original file that didn't have the low code, look for the low score stuff, and then the new stuff. Okay, so it's easy, it can track it, and it's got all kinds of information there that we don't care about right now. And what it tells us up top is, we're comparing our low score branch, and GitHub says, hey, you're able to merge. These branches can be automatically merged. We love it when that happens. Okay, we don't have a merge conflict, and so we don't have time to talk about merge conflict. So what I got to do is create a pull request. All right, and so added code, define and print a low score. Okay, I could add some more stuff, but I'm just going to say create pull request. Okay, and so this is interesting. We talked about push and pull. Well, what's happening here is we're actually pulling from one branch into another. Okay. It's a merge operation, but what we start by doing the pull request. Okay, and so then it says, hey, you can add some rules. But here's the important thing: this branch has no conflicts with the base branch, and so let's merge it. All right, and then finally, it really wants to make sure we know what we're doing. Okay, and this is a good thing. You might think it's busy work, but it's a good thing. So I'm going to say confirm merge. Now it says merging. Okay. And it even tells us this: pull request successfully merged and closed. You're all set. The low score branch can be deleted. So if I was done what I was doing because I took the differences, I put it back in main, I could get rid of this branch if I wanted to. I'm going to leave it. Okay, now we're about to run out of time. So, anyway, we merge stuff, and what I can do at this point, okay, is I'll just go back. And I can switch to, it's on the main branch here. And if I look at test scores.ty, all right, it's got the code for min score. Great. So as we run out of time, just so you can see this, all right, I have this little IDE open. Oops, where did it go? Where did my chart? There it is. So here's PyCharm, and I got some other stuff here, but it doesn't matter. All right. And so it's giving me a tip. So I'm going to close the project here. And I want to get something from a version control system. All right. And I want to go to GitHub. And so then what it tells me is I need to log in to GitHub. Well, I'm already logged in. And so then I can just say authorize. All right. And so then it says, okay, you're successfully authorized. And so now I go back here and it shows me all the things that I have here on GitHub, and I have a lot of stuff. And so here's CLS workshop demo. And then I click clone. Clone, we learned about clone. And so this pulls everything from GitHub down, and this PyCharm IDE, okay, it even gives me information about it. And it just made a project, and here's my test scores.py. Then I can run it. And down below I see high score. Make this a little bigger for you guys. So high score, low score, average score, right? And there's the source code. It could be that easy. This is beautiful stuff. Beautiful stuff. Okay? Love it. Coding's cool. Git makes it even more cool and easier. So let's finish this up because we're out of time. I need to switch back to and switch this back to that one. And so the last thing, so it's what I also did in these slides, okay, is I did screenshots of what I just showed you on GitHub. So these slides will be posted. And so the last thing I wanted to show is that there are some resources. So if you want to learn how to use GitHub and the flow, there's a nice little link here to that. And then, if you wanted to run Git on your local machine from the command prompt and type stuff in, there's a link there. There's some tutorials, there's some training. And so all of this is posted to our CLS website. And you can go grab this presentation, the associated pieces. But the other thing is, I'm a resource for you too. Send me an email if you got questions. I'm glad to help you with this, because it's fun stuff. So I think that's about all we have time for. We're running a little bit over. Do you guys have anything else you want to say or talk about? Thanks for making time out of your day. Appreciate it. Now you know a little bit about versioning. Cheers. We'll see you.